Hello students, welcome to the physics world. Today we are going to study electricity. First we are going to start with a very basic simple circuit. This is a battery. These are connecting wires. We have a bulb here. If you consider a battery, this is a negative terminal. This is a positive terminal. Here lots of electrons are here. You know electrons have negative charge, and this is here we have positive ions are here. You already know that opposite charges will attract each other. So you may ask whether these electrons will go and reach this positive, but it will not happen. The reason is here we have something called electrolyte. It will prevent these electrons to flow from here to here. So the only way for these electrons to reach this positive side is externally. So when we connect it with these connecting wires, what will happen is these electrons will start moving in this direction towards this positive side. So charge of the electron is, so I say QE is equal to 1.6 into 10 to the power minus 19 coulomb. Say in a 10-second period, 10 to the power 20 number of electrons move. Time t is 10 seconds and the number of electrons is say 10 to the power 20. So the total charge moved during the 10-second period is equal to 10 to the power 20 number of electrons multiplied by the charge of the electron. Actually it is a minus because electrons have a negative charge. So it is minus 1.6 into 10 to the power minus 19 coulomb. So you will get 16 coulomb. The total charge moved in that 10-second period. There is a definition for the current: delta Q over delta T. Don't get confused with this delta. The meaning of delta is change. What is the change in the charge divided by the time period? So simply you can remember Q over T. So here I is equal to, we already found the total charge transferred during the 10-second period is 16 divided by the time is set 10 seconds, so 10, so 1.6. The unit for the current is ampere, so it is 1.6 ampere. But as we already know, here is a minus, this is minus 16 and this is minus 16. So minus 1.6 ampere in this direction. So it is equal to minus 1.6 ampere in this direction. But we want to tell everything in plus. So instead of telling minus 1.6 current move in this direction, we want to tell 1.6 ampere plus 1.6 ampere current is moving in this direction. So this is called electron flow and this is called conventional current flow. So from now onwards, we forget about this electron flow. We will talk about this current flow in this direction, from plus towards minus through the external circuit. Say in this circuit, if I say the voltage of this battery is say V and the current passing through this circuit is I, the resistance of this bulb is R. There is a relationship between R, I and V. R is equal to V over I. R is a constant value when the temperature of the resistor is not changed. So if the temperature is not changed, R is always constant. So V is equal, if in this equation, if I cross multiply, V is equal to R I. So it is like a Y is equal to mx format. y, m is a constant, x is varying. So if I draw a graph between P and I, you will get a straight line going through the origin, and the slope will give you the value of R, that is the resistance of this resistor. Say we have an unknown resistor and we don't know what is the value of this R, and we are going to find it now. For that one, we connect that resistor with a battery. Say the battery voltage is 5 voltage. Then when we connect it with these wires, assume that these wires are very ideal, so they don't have internal resistance. If there is no internal resistance, then there is no energy loss or voltage drop in these wires. So if I say this is point A and point B, the voltage or potential difference between these 2 points of this battery is 5 voltage. If this is A and these are the ideal wires, we can say all these points are A. Here, up to here also, all are A, all are similar. So like that, if this point is B, we can say this is B, this is B, this is B, this is also B. So if I say the voltage across these 2 points is 5 voltage, AB, you can say the voltage across these 2 points also 5 voltage. The potential difference. That is for an ideal condition. For simple questions, we assume that there is no internal resistance, but in the next levels we will study about the internal resistance also. So at the moment, just consider it is just ideal. So we can say this is the 5 voltage. Now we are going to find about, even though we say it is 5 voltage, we can measure it. For that one, we are going to connect a voltmeter parallel to this resistor. We can't connect a voltmeter like this. If we do it like that, there will not be any current through this circuit. We can study these things later. Now, just understand that we will connect the voltmeter parallel to this resistor. So this voltmeter will measure the potential difference between these two endpoints of this resistor. We are going to measure the current going through this circuit. For that one, we have to connect the ammeter series to the resistor. So if you divide this one, your ammeter is series to the resistor and your voltmeter is like parallel to the resistor. And in these experiments, we assume that this ammeter has got a resistor 0. So RA is 0, and we say that the resistance of this voltmeter is infinite. We assume that this ammeter is an ideal one and this voltmeter is also an ideal one. If the resistance is 0, there is no voltage drop across that component. So there is no voltage. So voltage across these 2 points will be 0. And like that, if you consider this voltmeter, as the voltmeter resistance is infinity, we can say that there is no current. So IV is equal to 0. The current going through this one is 0. So whatever the current coming through this circuit, so if I say I, same current is coming, it is I, and in here also it will go in, and there is no current through this loop. We already studied R is equal to V over I. So we connect the battery, read all these readings. If all of them are ideal, this voltmeter will read 5 voltage. In a real world condition, we can't get anything as a real. So there will be some internal resistance here, and this is not an infinity. Definitely there will be a small current going through this one. There are some internal resistance in the battery. So due to all these reasons, this voltmeter reading will not be 5 voltage. It will be less than 5 voltage. Say 4.5 voltage. And if I say this current is like 0.1 ampere, if the ammeter is reading 0.1 ampere, then we can put that one in this equation. V is equal to 4.5 divided by the current is equal to 0.1. So you will get 45. The unit of the resistance is ohms. So we can tell it like that. But we already studied that one, these meters are not ideal. So calculating the resistance with a single value is not correct. So to find out the resistance, we come up with a different method. We are going to connect another resistor here, but it is a variable resistor. The symbol for the variable resistor is like this. If it is a fixed resistance, if the resistance is fixed, we will just put R. If it's a variable resistor, then we will put an arrow like this. That means you can change the resistance of this variable resistor. Now, if I say this is 5 voltage, we can't say this voltmeter also going to read 5 voltage or close to 5 voltage. The reason is, so in the previous diagram I showed, if you have a point A here, say you have a point A here, you have a point B. If you assume, okay, this ammeter does not have any resistance, we can say this is also same as A, and this point is A. And like that, if it is B, and this point is B. Now, if I say the voltage across this point is 5 voltage or 4.5 voltage, something like that, we can tell that the voltage across these 2 points are 5 voltage or 4.5 voltage. But I can't tell that this voltage is also close to that 5 voltage, because that complete voltage is applied across these 2 points. So there will be some potential difference between this component as well as some voltage across this component. For example, say if I say it is 5 voltage, say 3 voltage, 2 voltage, or 2 voltage across this one. Say 2 voltage and 3 voltage, 1 voltage, 4 voltage. So when you add both of them, it will give you the potential difference across these 2 points. This is just an example. Okay, now we come to the problem. Say we set up this one, a battery, ammeter, variable resistor, the resistor that we want to analyze, and this is a voltmeter. We connect it like this. Normally, okay, you already know we will have a switch also for the safety reasons. So what we are going to do is, we are going to change the value of this resistor, this variable resistor, and at the time we are going to take the value of ammeter and the voltmeter. If I put it in a table, say I and V. So ammeter reading is coming here, the voltmeter reading is coming here. I set this variable resistor and get the values A and B, and I mark it here, and I change it to another value. So at that time, you know that the value of A and B, the value of A and B will be changing. So I get it. So we change the value of this variable resistor and we get the corresponding values of ammeter and voltmeter, and we put it in this table and we plot the graph for V and I. So for different values we are having these points. So if you put the points like this, if you join it, that straight line will go through the origin. There may be some points out little bit outside this line also, but we have to find the best match line and we have to draw it. It will go almost through the origin. And we already studied R is equal to V over I, V is equal to IR. So if I rearrange, V is equal to RI, so it is Y is equal to MX format. So if V is in Y axis, I is in X axis, the gradient of this line will be giving the value of the resistor. To find out the gradient, you may already know, if I say this point is, say this coordinate of this point is x1, y1, if it is x2, y2, so you will write m is equal to y2 minus, this length is y2 minus y1 divided by this length x2 minus x1. So it will be equal to, if you find out this value, that is equal to the R. So here instead of finding the value of R with single voltmeter reading and ammeter reading. We get lots of values, plot the graph, find the best match line, then find the gradient of this line to find out the resistance. This is the better way than finding the value of resistance with a single measurement. So the relationship between R, V and I is given by R is equal to V over I. So from here we say that V is equal to Ri. So R is a constant. So it is like a Y is equal to mx kind of format. So if we draw this, we already know this is Vi, this is a straight line. So we assume that the resistance of this resistor is not changing. So from here there's a law called Ohm's law. The Ohm's law says the potential difference across a metallic conductor is proportional to the current passing through that conductor if the physical conditions does not change. The physical conditions means that mainly the temperature. If the temperature increases, when the current passing through this conductor, the temperature will increase. So when the temperature increases, the resistance of this resistor will increase normally. Using some cooling mechanism, if we keep the resistance constant, then we can achieve this kind of behavior. The V will be proportional to the I. That is the Ohm's law. Now we are going to study about some characteristics of the resistors. Say we have a resistor 1 and resistor 2. So when I say R1, the resistance of this resistor is R1 ohms and the resistance of this resistor is R2 ohms. So if you connect like that, in a, say you have a circuit like this, R1 and R2. Okay, we have two resistors like that. I want to replace this R1 and R2 with a single resistor. So in that case, I want, if I have a current I is going through this circuit, say this is the battery voltage, same battery is used here. I want to have the same current in this circuit and I want to replace these two resistors with a single resistor. So we are going to find that value of R. So this R will be given by R1 plus R2. So if I say this is 10 ohms, this is 20 ohms, equivalent resistance is 10 plus 20, 30 ohms. So you can replace these two resistors with a single resistor of 30 ohms. Let's prove it. So in this series circuit, we have the V here, I is here, R1, R2, same V, same I. We are going to find the equivalent single resistor here. So same current I is passing all the way to here. So in this circuit, the voltage of the battery is divided across these two resistors. Say if I have a voltage across these 2 points are V1 and the voltage across these 2 points are V2, then we can say V is equal to V1 plus V2. So if you use the Ohm's law here for this resistor, current going through the resistor is I, the voltage across these points are V1. So we can tell V is equal to IR formula, V1 is equal to IR1. Same thing here, current is I, the voltage is V2, so we can say V2 is equal to IR2. We already know the voltage across this battery is equal to the voltage across this point and this point. That same voltage is divided into two parts here. So if I say this is a 10 voltage, it may be 5.5, 4.5, 3.5 based on the value of this resistance. So we can say V is equal to V1 plus V2 here. That's what we already told. In the second circuit also we can say V is equal to IR. So if I put it in this equation, IR, so in this equation, IR is equal to IR1 plus IR2. All i's are cancelled. So R is equal to R1 plus R2. So if you have the resistors in series, to find out the resultant resistor, you have to add it. Now we are going to study about the parallel resistors. Say you have a resistor R1 and R2. You are connecting like that. We are going to replace this one with a single resistor. Say if you consider this circuit, I am going to replace that one with an R. Same battery. Here 1 over R is equal to 1 over R1 plus 1 over R2. We can prove this one. Say we have a V here, say I am having a current here I. So when the current is coming this way, this current will be divided into these two roots. Some I1 will be going here, the rest of the current I minus I1 will be going this way. So if you add these two, you will get this I. After that one, I1 is coming this way, I minus I1 is coming this way. So they will combine together. So I1 cancelled. So this I will be going back to the battery. So if I have a V voltage here, I already told if you have a point A, same A points, here also you can say A. So if I say this is B, B, B. So if the potential difference between these 2 points are V, we can say the potential difference between these 2 points also V. We already know an equation, V is equal to IR. So if I apply that one to this resistor, if the potential difference between these 2 points are V, same way we can say the potential difference between the two endpoints of this R1 is also V. But we know the current going through this one is I1. I mark this one I2. So same V is equal to I1 R1. If I apply the same rule here, same voltage, same potential difference, V is equal to I2 R2. So we told that we are going to find the equivalent resistor here. So same I is going through this one. If this is V, the potential difference between these 2 points are V, I can write an equation V is equal to IR. I can say I is equal to I1 plus I2. The I is equal to I1 plus I2. From this equation, I can tell I1 is equal to V over R1. From here, I can tell I2 is equal to V over R2. And here I can tell I is equal to V over R. So if I put these values here, I is equal to V over R equal to I1 is V over R1 plus V over R2. V cancelled. 1 over R is equal to 1 over R1 plus 1 over R2. So this is the way we derive the formula. Say if R1 is, for an example, R1 is 2 ohms, R2 is 3 ohms, then in this equation 1 over R is equal to 1 over 2 plus 1 over 3. It is 2 plus 3, 5 over 2 times 3, 6. So 1 over R is 5 over 6. R is, if you switch it, you will get 6 over 5 ohms. So here what we are doing is, we multiply this and divide the additions. Say, if you have 2 and 3, you can simply say 2 multiplied 3 divided by 2 plus 3. So 6 over 5. So in a multiple choice question, if they ask any questions like this, simply you can, instead of writing all these formula, by practice you can do that, multiply it and divide by the addition, you will get the answer straight away. Because how it is coming is 1 over R is, if you get the least common multiple, it is R1 times R2. Here it will be R2 plus R1. So if you get the reciprocal, R is equal to R1 times R2 over Now we are going to do some questions in this area. So if I have a resistor 10 ohms, another one is 30 ohms, the resultant resistance will be equal to 10 plus 30, it is 40 ohms. How? R1 plus R2. It's coming from R1 plus R2. So if I have a resistor like 10 ohms here and another 30 ohm here, here the combined resistance to find out 1 over R is equal to 1 over R1 plus 1 over R2. So if you have three resistors like this in parallel, R1, R2, R3, then you will do 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3 if it is in parallel only. So here there are two resistors, so 1 over R is equal to 1 over 10 plus 1 over 30. So these common multiplies 30, 10 times 3, so 3 plus 1 over R is equal to 4 over 30. R is equal to 30 over 4. It's 15 over 2, so it is 7.5 ohms. Here I want to tell something. You can have a circuit like this. You can have a circuit like this. Say R1, R2, R1, R2. All are equivalent. You can have it like this and have a junction, and you can connect this one, this loop into this junction. Or you can have it like, instead of this straight line, you can have something like this. All are same. There is no difference. So in a circuit, if you have battery, you can have resistors like this. It is equivalent to having a circuit like this. This circuit is equivalent to this circuit. We already studied. If I say this point is A, this point is A, this is A, this is A, this is also A. So I connect all of them together to make it here A. Same thing, this is B, 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 B. I pushed all of them together to make it here. So if I say current I is passing, same current I is passing here. So if I say I1 is going this way, I2, I3, then all of them will combine together to form that I. So same thing here, I can say I1, I2, I3. I is equal to I1 plus I2 plus I3. 10 ohms here, and it is connected with 2 ohms, 3 ohms. I asked the resultant resistance for this one. Here we have to do part by part. If you consider these two resistors, they are parallel to each other. So these two are parallel, and to that parallel one, if I find an equivalent resistor for this one, then we can tell this is series to this one. So first I consider this one. So 1 over R is equal to 1 over 2 plus 1 over 3. So it is 5 over 6. So R is equal to 6 over 5 ohms for this one. So now you can think this is 10 ohm. It is series to another 6 over 5. So 6 over 5 means 1.2 ohms. So 1.2 ohms. So 10 and 1.2 ohms are series now. So 10 plus 1.2. So final answer is 11.2 ohms. So simply we can replace this one with a single resistor, 11.2 ohms. And if you consider these two resistors, forget about this one. Here 2 and 3, the answer you got is 1.2 ohms. So always remember that in a parallel circuit, the resultant resistance will be always less than the smallest resistor. So here if you consider 2 and 3, this 1 by 2 is less than 2. If you get some answer, it is greater than this 2, then that means you are doing something wrong. In a series circuit, your answer will be always greater than the biggest resistor. Say here 10 and 1 by 2 are here, your answer is always greater than 10. You got 11.2. If you got something like 9.8 or something, that means you are doing something wrong. In a series circuit, your answer should be greater than the biggest resistor. In a parallel circuit, your answer should be less than the smallest resistor. Say you have n number of resistors. Every resistor has a resistance of R. So R, the resultant resistance is equal to R plus R plus R up to n times. So it is NR. So if you have a parallel circuit up to n, all of them are R. 1 over R is equal to 1 over R small r plus 1 over small r plus 1 over small r up to n number of times. So this is 1 over R is equal to n over small r. So R is equal to small r divided by n. If I say R is equal to 100 ohms, we have 20 of them are there. So the resultant resistance will be 100 divided by 25 ohms. So that's the end of the class today. We studied about the resistors and the Ohm's law and the series resistors and the parallel resistors. So in the next session we will continue from here. If you have any questions, you can ask in the comment sections. If you want further help in physics for GCSE or A-Level, please feel free to contact me. Thank you.